This is Pre-Calculus Onramps, homework 3.3.2, the Logistic Growth Model. This is not difficult, and it involves the same manipulations that have been going on for compound interest, for all the other subjects in the log chapter or unit 3, which is eventually taking the log of both sides so you can either get rid of e's or move exponents to make them just numbers. But you have to know that the logistic model, this K, this carrying capacity, where they explain the model over here, why can't I zoom in and keep this thing centered? I don't know. K, the carrying capacity equals the maximum population that environment can carry or can sustain. So, maybe it's 120. There can be 120 deer on a certain island because the amount of food and the amount of water and the way the predator them, eat them, hunt and eat them, allows for 120 maximum population. So here's this says on a college campus, 5,000 students. So the carrying capacity is 5,000. That's the maximum number of people involved in this thing. One student returns from vacation with a contagious and long-lasting flu virus. The spread of the virus is modeled by f of t equals 5,000. 5,000 is k, so that's the maximum amount, divided by 1 plus 49999, or 4999 e to the negative 0.8t, where f of t is the total number of students. So you can see the most students that can be infected is 5,000. The college will cancel classes if 40% or more of the students are infective. Graph the function and sketch it. Label appropriate domain and range. Well, these look like they look like S's when it's a logistic curve, where the halfway mark is half to the carrying capacity. So in this case, that's going to be about 2,500. And the asymptote, it's going to approach but never reach 5,000. So I just have to figure out, I'm just going to put some things there. This is 5,000. I'm not going to use the same scale. This is 2,500. So that's number of people infected. This is asymptote. And so what's the domain? Well, I think the solution shown for this homework says the domain is negative infinity to infinity. Well, it can't be to negative infinity because you don't go days before the infection. So I'm saying the domain is 0 to infinity. And then the range, you can either say it's 0 to the carrying capacity, 5,000, but it never actually reaches it. Or it could be 1 to 5,000. It starts with one student. So graph the function. I need to find where this inflection point is. Where's the halfway point? How many days after this thing starts does it reach 2,500? So I'm just going to take this function. I'm going to say 2,500 equals 5,000 divided by 1 plus 4,999 e to the negative 0.8t. I'm going to multiply both sides by this denominator and divide both sides by 2,500. 5,000 divided by 2,500 is, not 25. Wait a minute. Oh yeah, I'm trying to find the inflection point. I don't know what I'm doing here. Later on, I have to use 2,000. So 500 divided by 2,500 is 2. 1 plus 4,999 e to the minus 0.8t equals 2. I subtract 1 from both sides. And then I'll divide both sides by 499. E to the minus 0.8t equals 1 over 4,999. Now take the natural log of both sides. Natural log and e undo each other, so I have negative 0.8t equals log of 1 over 4,999. They're inverse functions. So technically this negative 0.8t, I shift down to the front of that. But it's negative 0.8t equals natural log of 1 over 4,999. And then I will divide both sides by negative 0.8, so I get t equals the natural log of 1 divided by 4,999 divided by negative 0.8. And that will tell me this middle point, and I'll do this on Desmos, log of 1, whoops, not can, natural log of 1 over 4,999 divided by negative 0.8 equals about 10.6. So this will be 10, this will be 20, was it 10.6? I guess it doesn't matter because I'm not going to. So about here is where the middle inflection point is, so it's going to go from 0 to that, and then it's going to start slowing down in its rise and keep approaching 5,000, and then that's 0, 1. So that's approximately what the graph looks like with the inflection point at 10.6, 2,500. So it looks like that. It's supposed to look like this. Maybe mine doesn't look too good, but that's what it's supposed to look like. All right. I think I did that pretty good. Yeah, maybe. All right, so it rises very fast, then it hits that inflection point, the middle point, and the middle point is half of the carrying capacity. So that's that one. How many students are infected after 5 days? Well, I just type in the equation and I put 5 for t. So I'm going to put f of x on Desmos. F of x equals 5,000. You can do this on your TI-84. Watch out for those parentheses. 4,999 e raised to the negative 0.8 x, and then I'll put f of 5, because x is 5, about 54 students. Does it say? Yeah, it doesn't say 54. So it's going to be the formula where x, 5,000 over 1 plus 4,999 over e, times e to the negative 0.8 times 5. And then that will be the exact number, and approximately 54 students. Then it says, how many days will the college cancel classes? Well, it has to be at when 40% or more are infected. Well, 40% of 5,000 is 2,000. So now I'm going to do the same thing. Multiply both sides by this denominator, divide both sides by 2,000. 5,000 divided by 2,000 is 2.5 equals 1 plus 4,999 e to the minus 0.8 t. I'm going to subtract 1 from both sides, then divide by 4,999, so I get 1.5 divided by 4,999 equals e to the minus 0.8 t. I'm going to take the natural log of both sides. Natural log and e are inverse functions, so I just have negative. Technically, I'm taking this negative 0.8t and multiplying that in front of there. But negative 0.8t equals natural log of 1.5 over 4,999. So I divide both sides by negative 0.8, and that equals just t. So I will do this on Desmos. I will do natural log of 1.5 divided by 4,999 divided by negative 0.8, and it equals about 10, approximately 10.14 days. And, so 10.14, how long is a school day? 8 hours? I don't know. 0.14 times 8 is 1.112 hours. 0.112 times 60, 7.2 minutes. So about an hour and 7 minutes into class. Attention students, school is canceled. Everyone go home. Please walk one at a time in the hall so that no one else gets infected. Do not take the bus, walk home, or drive your cars. So they will want to separate the students at that point so no one else gets infected. But those are the answers, and that's just one of the questions on homework 3.3.2, which is the logistic growth, population growth.